Hello everyone and welcome to the owasp course. In this course I try to explain some basic concepts and problems related to security during the development of our applications. So OWASP stands for Open Web Application Security Project, and it's an open community with the aim of enabling organizations to develop, sell and maintain applications that can be considered secure. And all OWASP tools, documents and forums are free and open to anyone interested in better application security. We indicate the application security approach as a technological, process and people problem, because an effective approach to application security includes improvements in all areas. And for sure you can find much more information on OWASP site at owasp.org and on Fortify site. Fortify is a tool to discover security issues in our code using static and dynamic analysis. But what we must consider when we say OWASP? In kernel applications, we need to monitor 5 possible attack surfaces. The first one is client-side, so our code written in JavaScript. The second is web server with IIS configuration. And then we have the free pipelines, ASP.NET with lifecycle of pages and handlers, static contents such as, for example, CSS, images, and last, the behavior related to Web API. It's important to keep in mind this distinction because not necessarily all the automatisms that apply to ASP.NET and system.web also apply to the other parts. For each, additional consideration may be required, but many are already present in kernel. And for all these points, the highest point on which we can do something is represented by HTTP filters, while the lowest one by a good error handling strategy. During the development of our applications, we have to take care about 8 security macro areas. And for each of these, we will try to deepen by seeing some known problems. The first one is securing session and authentication. And then we have cross-site scripting that enables attackers to inject client-side scripts into web pages viewed by other users. We have sensitive data and content protection, injection such as SQL, XML, JSON, and dynamic code injection, navigation and direct object reference, exception and error management, so we have to manage errors in a efficient way, null dereference and the right release of resources to avoid performance problems, and last, transport layer protection and SSL certificates. Within kernel, there are already a series of implementation for error handling and filters related to web APIs. And those that are configurable, have default configuration in CAM web config that cover general use cases. There are also helpers used automatically by kernel-based pages which can also be used in case of custom pages. And if more specific configuration are required, these are documented inside Wiki. CAM contains configuration that are not strictly related to our application, but are proper of ASP.NET and IIS, so the System Web Server part. And same as before, there are only those related to general use, while the others are documented in Wiki. And in particular, pay attention to custom errors on static content that is not enabled by default. The first point is securing session and authentication. And here the problem is that we have to keep the session safe and non-interceptable. This to prevent a third person, called the man in the middle, from stealing session ID or authentication token of a logged user, having thus access to application and or session data. Man in the middle is a security attack where the attacker secretly relays and possibly alters the communication between two parts who believe they are directly communicating with each other. And for sure, we must not save the session in URL or expose the session ID in any way. Instead, at least, keep it in cookies. Session and authentication cookies must be HTTP only, and so they can be read and written only on server side. If SSL is used, then they also must strictly travel with it. When user log out, session token must be completely thrown away and not only reinitialized. And it is possible to configure timeouts to find the right balance between safety and the convenience of keeping the same session for a certain period. Remember that long timeouts are not a security best practice, and so we must be careful with the logics with which we set them, and evaluate when to make them expire, obviously also based on the business logic of the application. And another thing to remember, before put something in session, ask yourself if it is safe to do it. And in any case, all complex objects must be marked as serializable. This depends on the provider used to start the session. If it is in process, there are no problems, but 45, for example, cannot know it. Related to securing session and authentication, we already have something in kernel, and by default we have session and authentication cookies HTTP only. We have a login page as a base class for app login to manage the login process in a secure way. We have an improved error login to manage the case of missing user with Windows or Federate authentication. And also the auto-completion is disabled by default for forms. And we also have the possibility to use session and authentication cookies with HTTPS. From kernel version 4.22 or 5.19, cookies are set HTTP only true by default, and so they can be read and written only on server side. Remember that
to check HTTP only property for server-side cookies created in your application and remove it where not needed to set it to false. All client-side created cookies are automatically not HTTP only, so be careful about data stored into them. And for the download cookie named kernel download token, it's correct to set it HTTP only to false because it's created on server side. But it needs to be read on client side and it doesn't contain sensitive data. If you can't update the kernel, remind that the cookie that stores the session ID will remain not HTTP only, and this is not so secure. And we will see something else related to authentication cookie when we will discuss about protection of transport layer.
We also said that all complex objects stored in a session need to be marked as serializable. Storing a non-serializable object as an HTTP session state attribute can damage application reliability. By default, ASP.NET servers store the HTTP session state object, its attributes, and also any objects they reference in memory. If session is not stored in memory, for example, to have the possibility to scale with replication on multiple machines, you must serialize the HTTP session state object, which requires that all objects stored in it will be also serializable. And as you can see in this example, you have to mark my class with a serializable attribute, and also the referenced my second class must be marked as serializable.
The second point is cross-site scripting and anti-XSS. Cross-site scripting, it's a type of attack, and to make it not so simple, we can have 3 different types of cross-site scripting. The first one is called reflected, and you can imagine you enter data to the application, which is then echoed back without escaping sanitization or encoding. And it's possible to include JavaScript code, which is then executed in the context of the application. The second is called stored, and you enter the data which is stored within the application in a database, for example, and then returned later on in response to another request. Also, this data contains JavaScript code, which is executed in the context of the application. And the last one is DOM-based, and you enter data which modifies the DOM of the web page. This data also contains JavaScript that can be executed in the application context. It's quite similar to reflected XSS, but the difference is that in modifying the DOM, the data may not ever got to the server. And this changes how it can be mitigated, as server-side filters may not be effective. But for all these 3 types, the point is the same. We must avoid that malevolent content can be injected in our application and then reflected in our pages or web API, or in data, such as database or XML. And the prevention is mainly done on 2 fronts. Where possible, using intrinsic defensive capabilities of ASP.NET with advanced anti-XSS filter. We're not using ad hoc filters. And in addition to filters that can be overcome, we have always to validate inputs. In this way, we can make harmless any suspicious content, possibly even verifying the correctness of serialized parameters and or their pertinence with the application business. In any case, parameters must be taken from correct collection, such as request.queryString or request.form, and should never be used without verification or sanitization. And remember that some of these checks must also be applied to client side. Related to this point, what we already have in kernel. We have control rendering compatibility version and request validation mode correctly set in web config to be able to use the latest version of security management in ASP.NET. We have an anti-XSS encoder, at least with framework 4.5.2. Otherwise, we have to install anti-XSS nugget package. Validate request is set to false, removed from all pages and web config. And where necessary, for example, with text area HTML, content is encoded for post and then is then checked server side using a HTML sanitizer. And also we have a HTML sanitizer available inside the kernel project. And if we plan to use Web API, we have also an implementation of anti-XSS filter attribute for Web API controllers. And we have the possibility to use jQuery encoder to validate and canonicalize JSON contents inside the scripts. One possible problem related to cross-site scripting is value shadowing on server variables. Relying on HTTP requests to provide access to a particular server variable is not safe, as it can be overridden by the client. The HTTP request class implements an indexer to simplify access to its query string, form, cookies, and server variables collection. But remember, in that particular order. So, for example, here we have a method, is HTTPS, that on server side attempts to ensure the user is using an HTTPS connection, so a secure connection. But because the program uses the HTTP request indexer and the query string takes precedence, URL like this with HTTPS equal on in query string appear to be from a secure connection, even though they are not. So always remember to identify the correct collection to read and write values. In this case, the correct ones is server variables. Going back to cross-site scripting reflected, the problem occurs when a parameter inside the request, get or post, for example, contains untrusted HTML, CSS, or JS code, and this is reported in the content of the response, such as page, handler, or Web API. For new projects, all is set in a correct way. Otherwise, you have to remove request validation set to false from all your pages. Remember that without request validation set to false, if you want to use a text area HTML, you have to update kernel to version 4.22 or 5.19. And also you have to modify the web config to use the last version of anti-XSS filter, at least framework with at least framework 4.5.2. And you have to modify in this way inside the HTTP runtime tag. You have to set target framework to 4.5.2, request validation mode to 4.5, and also the encoder type with the string system.web.security.anti-XSS encoder. In kernel, there are also an implementation of the anti-XSS action filter attribute for controllers and arbitrary catch default and the arbitrary catch default extension method. So remember to decorate controller with any controller with this attribute. And the implementation of anti-XSS action filter inside uses HTML sanitizer, which is available in kernel, and it can be also useful if you need to validate a JSON on server side during a page life cycle. For example, when it's passed as an argument inside an async postback with update panel. And also remember to use the extension method in a correct way inside your controller methods. Arbitrary catch default validates input parameters and catches domain exception, in addition to all other types of possible exceptions.
Regarding sensitive data and contents protection, a possible problem can be autocompletion in forms, which is a privacy violation. Autocomplete is set to off for new projects. Otherwise, you have to set autocompletion off on each form tag inside your application. Another possible problem is represented by cross-frame scripting. It is the possibility of the application being inserted into another application through the use of an iframe. To avoid this in web config, you can create a custom header inside HTTP protocol tag. The name is xframe options and value must be set to same origin. This custom header is already present in kernel for new projects. And inside custom pages that are not inherit from kernel, call the register startup framebuster method. For example, inside the lifecycle method on init. And if we need to embed the application inside an iframe, there is the possibility to add a configuration to identify which domains are enabled or not. And update kernel to version 4.22 or 5.19 if the browser does not support HTTP xframe option header. And ever-coded passwords and encryption keys can also be a problem for Fortify. So avoid hard-coded password in code and pay also attention to names of variables such as password or key or something else. In particular inside client scripts, because they can be misunderstood by the Fortify analysis. And also any password, key or connection string inside configuration, inside web config, must be encrypted. The point 4 is the problem of injection. this topic is quite wide, but the point here is that we don't want that parameters traveling inside the application can be used to modify the behavior of the application. In particular, going to change content of deserialized objects with JSON injection, XML injection, or the meaning of queries performed on the data source with SQL injection. From point of view of XSS alone, this could be harmless strings, but once used in these ways, they could produce unwanted effects. And what we have seen before in cross-site scripting and XSS section is valid also here. We have API try-catch default extension method to validate web API models and handle errors in a efficient way. And if you plan to use web API, remember to use models as method parameters inside controllers in conjunction with API try-catch default. Remember to write query as command with parameters when an Hibernate is not used, and on client side, use jQuery encoder to validate JSON contents inside the scripts. One type of injection is JSON injection. For example, here we have a JSON object on which the role property has been redefined by an attacker. And if we use a dynamic JObject to deserialize the body inside the do something method, we have a permission escalation because it's an admin role now and not the previous default role. So the right way to avoid this problem is to use models, not a dynamic object. In this case, a model is do something DTO. Using models, we can avoid properties redefinition, make validations on the structure of the object, and also make validation on properties using specific data annotation attributes. The server-side structure of the input parameter can be a class when some properties should remain null, or a structure when all the properties must be declared. And if one is missing, the Ajax call will return an error. And to go on this demo, JSON injection is also possible on client-side code. So together with API try-catch default and anti-XSS filter on controllers, we have also to set up Ajax call in a correct way. And if the call is a post, we have to set content type to application JSON and use JSON.stringify before sending data. In case of get, data type must be JSON, and then we have to parse the response using JSON.parse. In both cases, we have to handle possible errors in a fashion way, but we will see this point later. And in conjunction with anti-XSS filter, we can use jQuery encoder library to canonicalize and escape values from untrusted JSON if they are used as parameters for JS functions to compose URL or rendered as HTML. And we also have the possibility to validate the structure of JSON and use different methods depending on what we have to do. For example, we can canonicalize untrusted data and eventually catch the exception. We can we can use the method encode for JavaScript to pass an encoded string to another function, another JavaScript function, or we can use the encoder for HTML method if we need to write HTML directly inside an element. All these cases are related to DOM cross-site scripting because we are only on client side, and the ASP.NET anti-XSS filter in this case cannot help in any way. Another possible type of injection is represented by SQL injection. And as in this example, if we have an hard-coded query like this, the ID document parameter can be easily changed in something like this. And as you can see, with or 1 equals 1, the behavior is quite different because now we are erasing everything inside documents.db. So to avoid the problem, always use common parameters when you are not using an Hibernate to perform queries. Another problem close to injection is represented by serializable delegates. In C#, delegate and lambda can be serialized, and this may introduce arbitrary code execution vulnerability on or after the deserialization process. And watching the example, we have a dynamic runner class marked serializable with a serializable attribute. And so in this way, also the field delegate is serializable. And an attacker can replace the method information inside the serialized delegate with one which points, for example, to the process start method. And it will lead to an arbitrary process to be created and executed when the executor method is called. So here we have a case of code injection. Point 5 treats problems of navigation and direct object reference. What you have to remember here is that we must not give direct access to entities, perhaps by simply combining query string or page name. And also we must not give anonymous access to folders and static resources, with a necessary exception for authentication page. In any case, make sure that the user has permission to view a certain page or entity. And even if the URL is not directly visible, you cannot assume it's safe. URL can in fact be recorded at different times during life cycle of HTTP requests. If navigation is based on external parameters, the destination URL must be validated. For example, with encoding, signification, or compliance of query string structure with destination domain. And what we have seen before in cross-site scripting and sensitive data and contents protection also applies here. One possible problem is open redirect, and it tells us that we don't have to do client-side redirects where inputs and the destination cannot be checked. So always use encode URI with document location href or encode URI component to escape a single parameter. And in this way we can mitigate the risk encoding the URL, but we cannot prevent browsing. In fact, this is still an open problem, because in our application we should have a sort of whitelist of possible allowed destinations, so that you can block any unauthorized destination. But achieving this, it's not so easy. Another owasp important point is the exception and error management. We must not display error messages and unhandled HTTP codes to user, thus revealing details of structure of our application and code, or lead to a denial of service attacks. Any unhandled exception must therefore be shown with an ad hoc page or message, and it must be as generic as possible and not show details such as stack trace, data types, or something else. And even HTTP error codes need to be masked where possible, except for REST calls, which are based on them. In kernel, we already have some great things, such as by default the custom errors configuration for ASP.NET pipeline, the manage API controllers unhandled exception set to true to handle the unhandled exception on web API. The verbosity of displayed errors is always controlled by the custom error mode that is set in ASP.NET. Unhandled exceptions are handled inside the global ASACs. We have a custom error page that inherits from a kernel-based page. And the correct management of HTTP errors inside the web config for location relative to web API. And also we can have the possibility to use the custom error page also for static contents. To rightly manage errors of ASP.NET pipeline, we need some configuration. For new projects, all things are already in place. Otherwise, you have to update kernel to version 4.22 or 5.19. And modify the web config in this way, setting custom errors mode to on. During development, you can disable custom error management to get more help. So set mode to remote only. In case of web API, you have also to set manage API controllers unhandled exceptions to true inside the full control settings section. Remember that custom error management on web API works only if custom errors mode is set to on or remote only, and also if we have API try catch default set in place correctly. In case of an error, API try catch default internally catches the exception, HTTP response exception, without propagating them, and instead it returns an HTTP response that contains different codes based on the exception type. Error code 400 in case of invalid input parameters, 550 for a domain exception, and 500 for any other exception. And also it returns a reason phrase related to the problem. Remember also that if you want to use the custom error page also for static contents, and you have web APIs, you need additional configuration to correctly manage errors in both cases. Refers to wiki to find the correct setup. And to be OWASP compliant and avoid the injection, we must also handle errors on client side. After an AJAX call, we have to validate possible errors and display the message in a correct way. We can use the method canonicalize of jQuery encoder to validate the structure of error response, as you can see in this example. And remember that over time kernel has changed, so based on your project you can have the object message or exception message inside your code, and you have to handle this difference, and so pay attention to this difference. owasp tells us that we can have an unprotected directory problem because all directories should not be accessible without authentication. If it is the case, you can solve in this way. For Windows authentication, we can remove all authentication exception in Octopus transforms. In this example, for example, for CSS. And for forms or federate authentication, put only useful files in transforms. Point 7 treats null dereference problem and right release of resources. And we have to optimize code by always checking that an object is not null before calling methods or accessing properties on it. In this case, the vulnerability could be exploited for a subsequent denial of service attacks or disclose implementation details. In the same way, attention should be paid to resources allocation. We have to release them promptly when they are no longer needed. And a well-known problem is the null dereference. An attacker can use a null reference exception to bypass security logic or to obtain a useful debugging information in subsequent attacks. So always check for null when using as operator, for example. Avoid using link first or default and similar if you know sequence has at least one element. Otherwise, always check for null. And avoid assigning start null value to variables when is not necessary, because they can be misunderstood by Fortify analysis and it's not a clean code practice. Regarding resource management, keep in mind that most unreleased resources issues result in general software reliability problems. An attacker can intentionally trigger a resource leak, being able to start a denial of service attack and run out a resource pool. So, remember to always use using to properly close any stream or connection and dispose all unmanaged resources. In this example, there is a stream reader and we need to properly close it when we have done. And also we have to properly close any SQL connection or transaction. Speaking about security on transport layer, one important thing is the difference between HTTP and HTTPS. HTTPS means HTTP plus SSL. secure socket layer. SSL is an encryption protocol to protect data sent through HTTP transport channel. There is also a new version of SSL named Transport Layer Security, TLS. But for both, the goal is to provide authentication, data integration, and encryption. As you can see in the upper part of the image, if we use only the HTTP protocol on port 80, everything is sent in clear through the channel. And in case of sensitive data, such as passwords, for example, it's not a so good idea. Anyone can easily see the content. Instead, if we use HTTPS, the connection is encrypted, and the identity of the caller is also verified with a certificate. And obviously, this makes sending content more secure and difficult to read from an external attack. Here we talk about transport layer protection and SSL certificates. Especially if the application is public, any communication must be done via HTTPS protocol. And we also have to ensure that all attack surfaces are forced to use it, without the possibility of going to the simple HTTP. The site needs to be correctly configured and must use certificates that support the latest TLS or SSL standards. And the application needs to be configured to work only with HTTPS protocol, even at cookies and Web API level. Connection to any external servers such as SQL or Redis or something else must also be made using HTTPS protocol. And remember that if you need to create a client-side cookie, HTTPS verification must be done during creation. And do not indicate routes with a protocol type specified within the application. Regarding transport layer security, in kernel we already have some things. Web API returns bad request error if HTTPS is active in a web config and the call is made on HTTP only. With a secure set to true, if page is called in HTTPS, a check is made on client-side cookies. And as we said before, this example shows that cookies can travel through HTTPS. In this way, all cookies created on server side are managed over HTTPS by default, and you don't need to set the secure property. But remember to check secure property for server-side cookies created in your application and remove it. If the flag require SSL is set to true, the browser will only send the cookie over HTTPS. Sending cookies over an unencrypted channel can expose them to network sniffing attacks, so the secure flag helps keep a cookie's value confidential. This is especially important if the cookie contains private data or carries a session identifier, for example. During development, you don't have to set the required SSL to true because there is no certificate, but only in production environments. Remember also that if the authentication mode is set to forms, you need to use HTTPS for authentication, and then you have to set the required SSL to true, also for forms tag inside the authentication tag. Otherwise, sensitive information such as passwords, for example, are sent in clear on channel. And when you create a custom cookie on client side, you have to manually set secure to true if page is under HTTPS. Relying on weak cipher suites to enable encrypted communication could allow an attacker to steal sensitive information. An application relying on SSL or TLS to ensure authenticity and integrity of data transmissions could be vulnerable to compromise if it fails to choose sufficiently strong cryptographic algorithms. The strength of protection mechanism is determined by the authentication, encryption, and hashing algorithms, collectively known as a cipher suite, chosen for the transmission of sensitive information over TLS channel. To verify the reliability, you can use SSLab site at sslabs.com, or you can download the SSL scan application. And also remember that if you can control IIS, you can set up it correctly. So use the safest certificate and set IIS to not accept a certificate with old SSL version. In case of Fortify tells you that HTTPS is not correctly set, maybe the problem can be that when HTTPS is enabled, all must go through HTTPS. And so you have to enable URL rewrite rules. And in this way, this redirect from HTTP to HTTPS and adds a new HTTP header for new browsers. If you use Azure Web Apps, they are already installed and you have to edit the web config. Otherwise, if you use IIS, you need to install the rewrite module feature and edit the web config. And at least one condition match, the rule is triggered. And remember that the redirect is permanent if redirect type is not set to temporary. And so the browser no longer asks the old URL. If it happens and you want to change some rules, you can clear the cache. And remember also that the rewrite tag must be inside the system.webserver tag in web config. Another transport layer security problem can be related to emails. And for example, an unencrypted connection to a mail server allows an attacker to carry out a man-in-the-middle attack. So remember to set SSL to true inside your send mail job. More or less, I think that's all. Thanks for watching.